Hi guys, we are live and I think you should be able to hear as well as see me. If that's the case, you can say yes. Okay, cool. So we are here to solve today's daily challenge problem. Did you get some time to try and understand this question on your own? How many of you attempted this question? If due to some reason you could not, then I believe you should give it a read now. Okay, somebody, Harsh, got it accepted. That's pretty good. By the way, to be honest, it's an easy question, although it has been tagged as medium, but it's an easy one. So the discussion will be a breezer again. Okay, cool. So let's read this question. It says that there are n pieces that are arranged in a line, and each piece is colored either character A or character B. And you are given a string where ith element is the color of ith piece. So it basically means that there are some items and the color of an item could either be denoted by capital A or capital B, and now you will be given a string and that string represents the color of ith item. Okay, now Alice and Bob are the two players who are playing a game, and in this game they are taking alternate turns. Now what they're doing is that the first thing is that they are going to take alternate turns. So first Alice will play, because the question says that Alice will be the first guy, and then Bob will play, and then again Alice, then again Bob, again Alice, again Bob. Now the rules of the games are that Alice is only allowed to remove a piece colored A if both its neighbors are also colored A. She is not allowed to remove pieces that are colored B. So that basically means if we have a string, let's say A, B, A, B, 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 A, something like this, then Alice can only remove the items whose color is A, provided a condition. The condition is that towards the left side of that item, the color should be A, and towards the right side of that item, the color should be A. So it means that this item can be removed, because you can see that right side is also A and left side is also A. Similarly, even this item can also be removed, and this item can also be removed. So many items, this can also be removed. But can I remove this? The answer is no. Although it's an A, it cannot be removed. Why? Because the left side is B, so it cannot be removed. And the rule says that both the neighbors should be A. She is not allowed to remove pieces that are colored B, so she cannot remove any item which is B. Okay, now exact same rule has been specified for Bob also. So Bob can remove a piece whose color is B, but only if the left and right are also B, which means this B can be removed, because you can clearly see that left and right, both of them are B. This B can also be removed because left and right are again B. But how about this B? No, it cannot be removed because left and right are AA, they are not BB. Now, so this is the basic rule, and this is the most important rule. Okay, the first two of them. The third rule says that Alice and Bob cannot remove pieces from the edge of the line. Edge means the first element cannot be removed. Of course it cannot be removed because the constraint says that if it's an A, there should be A towards left and right also, and if it's first element, there is nothing in the left. Similarly, you cannot remove any item from the end because there is nothing towards the right. Okay, now if a player cannot make a move on their turn, that player loses and the other player wins. So this is like a normal game, like players are playing, and if it's the turn of Bob and Bob cannot make a move, then Bob loses. Similarly, if it was Alice, then Alice loses. Now, assuming both of them are playing optimally, we have to return true if Alice wins. So true should be returned for Alice, and for Bob it should be false. Okay. So I believe the problem statement should be pretty clear to all. If you look at this particular case, who do you think will win? I think it has been explained also. Let's say this is what you have. So who's the first guy? The first guy to play the game is Alice. So when Alice plays, can she remove an A? The answer is yes. See, there are so many A's. There are 4 A's, but unfortunately there is only one A that can be removed, and that is this, because this is the only A whose left and right both are A. So Alice can remove this, and then the remaining string will be like that. Now when Bob's turn comes, then Bob cannot remove any B, because there is no B whose left and right both are B. So it means that Alice wins and Bob loses. Similarly, you can have a look at this example. In this example, when Alice plays the first turn, she realizes, hey, there is nothing that she can remove, so Alice loses. And you can take a look at other example. So is it clear to everyone? How many of you are absolutely clear with the problem description before we move on? Also, if you're clear with the problem description and you feel you have a solution to it, or you coded the solution and got it accepted, feel free to write your solution in the chat box. What according to you should be the idea? I want to hear your ideas first before talking about anything else. Because guys, to be honest, this is an easy question. So I would expect all of you to come up with something at least. Okay, Ranveer goes first. He says that count all the consecutive sequences of A and B, and after subtracting 2 we can get the overall count. Yeah, so Ranveer is thinking in perfectly straight direction, and that's right. How many of you agree with what he is saying, or you have an approach which is quite similar to what he just said? Okay, so let's understand a few things. You know, this problem would have been difficult if actions of Alice would impact actions of Bob. Let me remove the word actions. If the choices made by Alice would impact next choices for Bob. See, had this been the case that Alice makes a choice to remove a particular A, and that has a consequence on the next set of choices for Bob, then this question could have been a little tricky. Okay, but do you think that will happen? Do you think that a choice made by Alice would impact the next set of choices for Bob? How many of you feel it would not? If you feel it would not, you can say no. If you feel yes, it would impact, you can say yes. Yeah, so that's what I'm saying, that the choices made by both the guys are independent of one another. And to talk more about it, just look at this example itself. See, Bob can remove a B only if there is a B behind it and then there is a B in front of it. Correct? So only these B's can be removed. This is to be understood. Now, if Bob is just removing B's, and that too the B's which are sandwiched in between the bordering B's, would that have any consequence on the A's which Alice could remove? The answer is no. It would not have any consequence. Had it been the case that when Bob pulls a B out, then some A's are also removed. Let's say had it been the case that Bob was allowed to remove this B. If Bob was allowed to remove this B, and let's say as a consequence of that, this A was impacted and this A was also removed. Or for that matter, I would say, let's say Bob was also allowed to remove an A. In that case, the choice of Alice would have been impacted. Because if Bob removes this particular A, now Alice cannot remove this particular A given this rule. So it means that their choices, their decisions do not hamper each other. So this question becomes very easy. So all that we have to do is we have to find out the total number of moves for A, which is Alice, and total number of moves for B, which is Bob. Now I would ask you a very simple question. Can you calculate these two values? How many of you can calculate the total number of moves that A can make and B can make? A means Alice and B means Bob. Super easy, isn't it? See, for example, if you look at any consecutive sequence of A's, how many A's are there? There are 5 A's. Now which A's can be removed? All the A's barring the beginning and the end. So I can say that if this particular length is, let's say, K, then the number of A's that can be removed is K minus 2. Now this length is 5 and 5 minus 2 is 3. So I can say that 3 moves can be made by Alice. Also, when I look at another consecutive sequence of A, the length is 3 and 3 minus 2 is 1. So there is one more move for Alice. Another consecutive sequence is here, and this is of size 4. 4 minus 2 is 2. So I'll do plus 2. Here what will you do? From this consecutive sequence, can anything be removed? The answer is no, because this length is 2 and 2 minus 2 is 0. So nothing can be removed. Even if you do plus 0, there is no impact. From this particular consecutive sequence, nothing, because its length is only 1. 1 minus 2 is minus 1, and I don't want to do that. So basically all that I have to do is I have to scan this string for the consecutive sequences of A, and then for the consecutive sequences of B. Now while I am doing that, I can easily populate the value of total moves for A and total moves for B, and then I can have my job done pretty easily, isn't it? So what will be the logic after it according to you? So if, let's say, the total number of moves that Alice can make is let's say greater than the total number of moves that Bob can make, that means who wins? That means Alice wins. Because if, let's say, Alice can make 6 moves and poor Bob can only make 4 moves, that means after the 4th round of the game, when the 5th round is played, Alice will be able to make the 5th move, but poor Bob will not be able to make any move and he'll lose, right? So once I have computed this and that, then the final logic can be very simple, that if total moves for A turned out to be greater than the total moves for B, then the winner is Alice, otherwise the winner was Bob. And for Alice we want to return true, so here we will return true and here we will return false. Is the logic absolutely clear to everyone, that why we can compute total moves A and B, and even most importantly why the choices made were independent? Because this condition held true, so the logic that we wrote holds kind of true. So are you clear with all of these? Yes or no? If yes, we can probably move on to the coding part of it. Okay, this question is from those people who did not code this question in the daytime. Do you feel now you can code it? After we have discussed it, do you have enough confidence to code it on your own? Trust me, it's super easy. Nothing that's tricky. So let's say if I wish to code it, I would say that, hey, I will have a variable called as moves A, which is 0, moves B, which is also 0, and I basically have initialized the total number of moves for A and B. And now I would say that I'll start with my current character, which will be nothing but my first character, which is colors of 0. Okay. Now while I'm scanning the string, I would want to figure out the streak of this particular character. Streak means that what is the consecutive length of it. Okay, so to start with, I would say that, hey, the streak value is 1, because right now I have just seen an A, just one A, so the streak is 1 right now. Okay, now I'll start scanning this string from index 1 onwards. So I'll go ahead, write my code, else for int I equals to 1, I smaller than colors dot length, and I plus plus. Now here I have to write some piece of code. So what should I do if the colors of I is equals to current character? What should be done? Like here, you found out that the current character, which is your ith character, is same as your current character, that was A. So if this is the case, that means the streak must be increased. So I'll just do streak plus plus, correct? Else, what do you think should be done? Else means that the moment you reached here, that means now the streak has broken. Now that the streak has broken, so we need to update either this or that, depending upon what our current character was. So I would say that, hey, you know, if my current character so far happened to be capital A, that means what I need to do is I need to update this value, move say. Now, you know, should I simply add to it the value of streak minus 2? Will it be the right thing to do? I would say no. Why it will not be the right thing to do? Because what if the streak was 1? If the streak was 1, 1 minus 2 will be minus 1, right? And you don't want to subtract anything. So you can put an if condition, and you can also write a ternary expression. So I believe you guys know how to write ternary expressions. You can say that only if the streak happened to be greater than equal to 3, that is, if this condition was true, then this value should be injected or added to it. Otherwise, nothing. Otherwise, 0, right? What does else means? Else means that the character so far was B, so the same thing has to be done for B. So I would say that moves of B should be updated in this case. All right. Okay. Now, after updating either moves of A or moves of B, what is the next thing that we are supposed to do? Now we are supposed to reset the value of streak, because now if you got a B, a new streak is going to start. Okay, so now here onwards you would say that, hey, you know, this value of streak should be made equals to 1, and also now the current character should change. It should be equal to the ith character that I just saw, which is colors of I, correct? Okay, one more thing, guys. By the time this particular loop is over, do you think we would have everything with us? Do you think we would have captured all the set of moves? The answer is no. An edge case could remain. What kind of edge case? Think of it. See, whenever you move to the else case, whenever you see a new character, then only you add the contribution of your current streak. Okay? Now, if you were iterating on this particular segment and your string ended, if your string ended, that means you did not add the contribution of this thing, because after this B there is no A. So, you know, beyond this particular for loop, I need to adjust that. In order to adjust that, I don't have to do any special work. I can in fact copy paste this same piece of logic. That's it. So I can just say that, hey, at this point of time I have a particular value of streak. So what I'll do is I'll simply check that what was my previous character. If my previous character was A, then I'm going to update moves of A. Otherwise I'm going to update moves of B. Now there is nothing that is left over in the question. So as I said, I'll just compare moves of A against the moves of B. So if moves of A is greater than moves of B, who wins? Alice wins. And when Alice wins, what do you return? We return true. Otherwise, we return false. Let's run this code. Works. And then submit it. This also works. Yeah. So this was a very simple code for this very super simple question, I would say. Is it clear? How many of you are absolutely clear with the implementation, the code? Okay, awesome. Please repeat the last edge case. Okay. So I'll ask you one thing. Tell me honestly, how many of you believe that if you would have tried to code this problem, you may have missed out on this edge case? Anyone who believes that you may have missed out on this edge case? Lot of people do that. Lot of people miss out on it. Okay, so this is a very classy thing. Like whenever you are scanning a string, see, I'll first explain like what is this case all about. So if you truly understand this thing, you will recognize that when your current streak breaks, then only you add the contribution of current subsequence to either moves of A or moves of B, depending upon what was your ongoing character, right? Now for the last consecutive subsequence, will the streak ever break? The answer is no, because you will continue to get B, 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 and after this B there is no A, it has ended. So who is going to capture the contribution of this, which is 4 minus 2? You need to do it outside of the for loop for the last consecutive string. Is that clear now? Yeah, cool. So once you have done that, then there is nothing that is left and the problem is very easily solved. You know, whenever you encounter easy questions like these, the important thing is not to get the right solution, because almost everyone gets the right solution. The important thing is that how many attempts it took you to get to the right solution. Because if such kind of easy questions are asked from you, then you know, then the attempt is to see that how quickly you can code it, how cleanly you can code it. I mean, your code should be self-explanatory, the variable names and everything that you have used. Somebody reading it should be able to understand what's happening behind the scene. Okay, and also it should not take you too many attempts. Like if you do 4 or 5 submissions in a span of, let's say, 10 or 15 minutes, and then you say that you nailed this question in 15 minutes, that's not good. So the better thing is that you think twice or thrice and code only once. What people do is they code twice or thrice and think only once. Don't do that. Do you see what I'm saying? So take out a pen and paper, think, write your thoughts, and then finally get onto the code. So once you're very clear that all the edge cases will be handled, you're very clear with all the scenarios, all the control flows, then only you should start hitting your keypad. Otherwise you should just keep hitting your mind for all sorts of edge cases that may be there. I had told at the beginning of the class that this session is just going to be a breezer because it was a super simple question. How many of you guys have been able to ensure consistency? I mean, have you been coding these daily challenges very consistently? I would love to see some responses. I would want to see how many of you are actually doing that. Great. And you can see others who are not doing, you can see that yes, people who have been consistent, people who are consistent, they truly exist. So you can also be one of those. It helps. It really helps a lot. It improves your coding speed, coding fluency, and all such things, which matters a lot, especially in interviews. Okay. Awesome then, great. So that will be it. We can wrap it up today. Tomorrow's daily challenge we'll discuss again tomorrow in the night. Let's hope it's a slightly better question than what we had today. Okay, cool then. Bye everyone and good night.